Today we'll be starting physics. This is AS Physics 9702. Okay, in this course, the first thing that we need to know is what are physical quantities. Anything, when I say thing, it is not actually thing, it is any feature of something. Anything that we can measure is called a physical quantity. Okay. So, excuse me. So we can measure mass. It is a physical quantity. We can measure speed, physical quantity. We can measure temperature, amount of heat energy, intensity of light. We can measure frequencies. So all these things are physical quantities. Things that we cannot measure. For example, how much somebody loves somebody, or how much sincere someone is to someone. These things are not measurable. That's why they are not physical quantities. They are abstracts, and we cannot measure them. Now, physical quantities can be classified into two basic kinds. One is one is actually a basic quantity. Basic physical quantity. What is meant by basic physical quantity? These physical quantities cannot be defined in terms of any other quantity or quantities. So something that we cannot define in terms of any other quantity or quantities is called basic physical quantities. Actually, you can simply think that these quantities cannot be defined. We have to believe them as they are. All other quantities are made by one or more basic quantities. Such quantities are called derived quantities. Now, without spending more time on this, let's discuss what are the basic seven physical quantities. Basic quantities. Their symbol, their unit, and then units symbol. Now, the first one is Length, symbol L. Unit, meter. Symbol for unit, M. Mass, symbol for quantity. We will be commonly using small m for mass. Unit, kilogram. And remember, mass is only one basic physical quantity that has a prefix with the unit, kilo. Mostly students think that mass standard unit will be uh, gram, but actually it is not. And these are SI basic units. Now, next is time. Symbol T. Unit, second. Symbol for unit, small s. Temperature. Symbol for quantity, theta. Or sometimes we use, if it is an absolute temperature, we use capital T. Yeah. Symbol, sorry, unit, Kelvin. Unit symbol, K. Now, electric, current. Symbol, I. Unit, ampere. Symbol for unit, A. Now, intensity of light. L. Unit is candela. Symbol is CD. Then amount of matter. Symbol N. Unit, mole. MOL is there. So these will be the basic 7 physical quantities, and all other physical quantities are composed of these physical quantities. Okay. Let's say next heading is derived quantities. Now, what are derived quantities? Quantities that are made using two or more quantities is called derived actually are called drive quantities. Now, let's start with a simple example. Actually, I will take it as an opportunity so that you can get introduced to all the formulas that can, or all the quantities that are there in AS physics. Okay. So today we will be discussing a formula list for all the quantities that we are about to encounter in this AS and making their units. Let's see. Um, Quantity, formula, SI base unit, and then SI unit. SI unit. Okay. Now, let's say first quantity is area. The formula for area is length into width. Now, unit for length is meter, unit for area is meter as well. So it will be meter into meter, which will make it meter square for the SI base unit. And there is no SI unit for area. It is always measured in meter squares. Now, volume, length into width into height. Length is measured in meters, width is measured in meters, height is measured in meters. So it will be meter cube. And again, no SI unit for that. Third quantity, density. Density is mass over volume. What is the unit for mass? Kilogram. What is the unit for volume? Meter cube. So what would be the unit for SI base unit for density? Kilogram per meter cube. Okay. So these are SI base units for area, volume, and density. Now, just 1 second. Let's continue. First one here is speed. What is the formula for speed? Okay, I'm now writing the formulas, and you have to complete the SI base unit. Okay, and in a short while I will complete that, and you can compare your answers with me. Okay, so speed is distance divided by time. Mm, acceleration, A equals to change of speed divided by time. Mm, force. F equals to ma momentum. Mass into velocity. Impulse. Impulse is force into time. Then moment. Force into perpendicular distance. Work. Force. Work. W equals to force into displacement along the direction of force. Then kinetic energy. 1/2 mv square. This is kinetic energy. Gravitational potential energy. Mg into change in height. Now, spring constant. The formula F equals to Ke used for spring constant, where K is spring constant. Now, strain energy. One over two into force into extension. Elastic potential energy. Elastic potential energy and strain energy are the same things with two different names. Ke square, where K is the spring constant, okay? And you have already calculated the unit for spring constant in the previous part. Now, pressure. Pressure equals to force over area. Now, okay, not only you will be practicing how to find unit over here, you will also be practicing or having a list of all the formulas that you need to know for this whole course in AS. Let's see. Now, power equals to work done divided by time. Pressure equals to rho g h. We have already done one formula. Let's put another formula, pressure of fluid here. Then we have Young's modulus. Young's modulus is 4 F L, force into length, over pi diameter square E. Yeah. F is force, L is length, D is diameter, and E is extension. So this is a formula for Young's modulus. Then electric charge, Q equals to current into time. Electric potential, V equals to work done divided by charge. Electric resistance, R equals to electric potential divided by current. Now, electric resistivity, resistance into area over length. Okay. Now, let's see. I'm now completing the SI base unit and SI unit over here, and you can compare your work if you have already done it. Otherwise, you can see how I am doing it. Speed, distance over time. So it will be meter divided by second. So SI unit will be m S minus 1. Again, it has no SI unit. We use meter per second. Acceleration, meter per second for speed and second for the time. So it is meter per second divided by second. That makes it meter per second square. Again, no SI base unit. Now, force, F equals to ma. What is the unit for mass? Kilogram. What is the unit for area? Oh, sorry, my bad. Acceleration, meter per second square. We just found in the previous part, meter per second square. So it is kg multiplied by meter per second square. So together, it is the unit of force, kg meter per second square. And I will recommend that this is one of the very basic quantities, and it is used very often. So you should remember it. If you will remember it, it will be helpful. You should remember the SI base unit for force, SI base unit for work done, and SI base unit for um, electric charge. Because examiner in exam always gives you a question from these three: electric potential, electric resistance, or electric resistivity. Examiner always asks in exam, you will only find these three quantities whose SI base unit or SI unit examiner is asking you to calculate or find. So you need these quantities or their units for them. So let's see. Force is mass into acceleration, so kg into meter per second square, and it has a SI base unit. Sorry, SI unit. SI base unit is kg meter per second square. SI unit is newtons. With a symbol N. Okay. Now, momentum. Mass into velocity. What is the unit for mass? Kilogram. What is the unit for velocity? Meter per second. So kg meter per second. If it is per second square, it is force. If it is kg meter per second, it is momentum, which is also Newton second. Now, impulse. Unit for force, kg meter per second square. Kg meter per second square. Multiply by time is seconds. So there are 2 seconds now, S minus 2 and S plus 1. Together, they will make kg ms minus 1. Impulse has same SI base unit as momentum. Okay. And this is because impulse is change of momentum. Moment, force into distance. So unit for force is kg meter per second square multiply by unit for distance is meter. So now we have 2 meters, meter power 1 and meter power 1. Together it will become kg meter square per second square. And its SI unit is Newton meter. We got the same units over here, but for an entirely different quantity. Kg meter per second square multiplied by meter, making kg meter square per second square. And this kg meter square per second square has a name, joule. So SI base unit will be joule. Now, kinetic energy. And remember these constants, 1, 2, pi, they do not participate in the makings of units at all. So mass into speed square, mass is kg, speed square, meter per second square. They make the unit kg, meter square per second square, which is joule. Okay. Now, just 1 second. Okay. Now, potential energy, mgh. Unit for mass is kilogram. Unit for gravitational acceleration, meter per second square. Unit for height, meter. So together, it will be kg, meter square per second square. That's why gravitational potential energy is also measured in joules. Yeah. Now, spring constant. Spring constant will be K equals to F over E. Unit for force is kg meter per second square divided by meter. You can see that the meter and meter will get cancelled. So SI base unit for spring constant is kg per second square. And SI unit is newtons per meter. Now, strain energy, force into extension. Again, 1 by 2 is not doing anything over here. So it is kg meter per second square. Multiplied by extension is also measured in meters. Kg meter square per second square. Turning out that it is also measured in joules. Elastic potential energy. K, which is spring constant, multiplied by E square. Remember, the unit for K was kg per second square. Kg per second square multiplied by extension is measured in meters. So meter square kg meter square per second square. So it is also measured in joule. Pressure, force over area. What is the unit for force? SI base unit. Kg meter per second square divided by area, meter square. Oh, meter divided by meter square. So it is power m plus 1 and into m power minus 2. M power 1 minus 2. That should end up like kg m minus 1 s minus 2. This is known as pascals. So SI base unit is kg per meter per second square and SI unit is pascals. Any confusion till now to anyone? Okay. Now, power. Power is work done divided by time. Okay, I asked you to remember the unit for work done and energy, which is kg m2 s minus 2. If you don't remember it, you can work it out because work done is force into distance. You know the unit for force multiplied by distance. You can work it out. And if you remember, it will always make your life easy. Kg m2 s minus 2 divided by s. Oh, so s minus 2 into s minus 1, because when s goes upstairs, its power becomes -1. The unit will become kg m square s minus 3, which is watts. Now, another formula for pressure is rho gh. Let's check out whether this formula produces the same unit or not. Density. What was the unit for density? We figured it out in the first page, last quantity. Kg per meter cube. Multiply by gravitational acceleration, meter per second square, into height, meter. Okay. So how many meters do we have? M power minus 3, M power 1, M power 1. So I think it is, I think it should be kg m power minus 1 as power minus 2, same as force divided by area. So it will also be pascals. Now the big one, Young's modulus, force into length, diameter into extension, and 4 and pi, they won't do anything in the makings of unit because they are simple numbers without any unit. So force, kg meter per second square into meter divided by diameter, which is also measured in meter square. Diameter square means meter square, into extension, which is also in meters. Okay, now what we have here. We have 1 kg, then m power 1, m power 1, m power minus 2, m power minus 1. So it will be m 1 plus 1 minus 2 plus 1. So it is, sorry, minus 1. 1 plus 1, 2, minus 2, cancelled, minus 1. Oh, m power minus 1. So m power minus 1, s power minus 2. And we end up with the same SI base unit as Pascal. So Young's modulus is also measured in pascals. Now coming to the last but the most important units. Charge, current into time. Current is measured in amperes and time is measured in seconds. So SI base unit will be AS and SI unit is coulombs. Now, electric potential, work done divided by charge. Again, if you remember the unit for work done, it will be helpful. If you don't, then you can use the formula force into distance to find out what is the unit for work done divided by time. So it is kg meter square per second square divided by charge is AS. Let's see if you can figure it out yourself. What should be the final unit? So it should be kg m2 s minus 3. S minus 2 divided by s is s minus 2 minus 1, which is s minus 3. And a, when it goes upstairs, becomes a minus 1. So kg m2 s minus 3 a minus 1 is also known as volts. Now, resistance. Resistance is electric potential divided by current. So it is the same unit as you figured out in the previous part, kg m2 s minus 3 a minus 1 divided by a, leaving you with kg m2 S minus 2, A minus 2. And this is known as ohms, represented by omega. Now, resistivity is unit for resistance multiplied by unit of area divided by length. So kg meter square S minus 3 A minus 2 multiplied by m2 divided by m. So I can see that it should be kg m3, because m2 plus m2 minus 1 m3 S minus 3 A minus 2, and it is ohm meter. And in exam, I have only seen these last three examples most of the time. Examiner asks you to find for 3 marks the SI base unit for resistivity. If somebody can remember it, it is okay. I won't recommend it, but if you have a good memory, you can just remember. You can write it over there: kg m3 S minus 3 A minus 2, and you will get full marks for that. But uh, if you don't want to remember it, you need to know how to find it out. You need to know the formula for that, and then you can put the SI base unit of all the values over there properly, and then figure out the SI base unit by yourself. So we will be ending today's lesson over here. We'll resume from the same point tomorrow.